Hi, everyone. This is John Gamble from Corelight. We're going to get started in just a minute or two. Give a few people an extra minute just to dial in, and then we'll get started. So stay on the line. We're about to start. If you're just joining us, we're going to get started in just a minute. All right, let's get started. My name is John Gamble, and I will be moderating today's webcast. I'm a director of product marketing here at Corelight. We have a great panel of speakers today for you guys, and the topic, of course, is universities, network security, and BRO. So without further ado, let me just walk you through a quick agenda and some housekeeping. I'll be giving some introductions to the speakers you're about to hear from. I'll be talking a little bit about BRO, just as a background to level set everyone on the call to make sure everyone is kind of on the same page about BRO's capabilities and history and functionality. And then we'll dive into the heart of this presentation, where you're going to get to hear from four individuals who all have deep experience working in network security and university environments, and also great experience using BRO, the Network Security Monitor. And you'll understand exactly how they've been using it in their environments, implemented it, and the benefits they've derived from BRO. And lastly, we'll open it up to you guys for a Q&A, and we'll have a couple of discussion questions amongst the panelists, so you can ask them whatever burning network security question you might have at your particular university, or a question about BRO. They're here to answer those questions. And if you'd like to ask a question during the webcast, you can do that on the panel on the side, and we will get to it at the end. We're not going to be answering questions during the presentation. We're going to save that for the end. Today's speakers, we've got some great speakers here. So Fatima Banatwala is a security engineer at the University of Delaware. She has a security engineering background as well and holds the CISSP certification. Nick Turley is also joining us. He is, let me just hide this panel, sorry. Nick is a security architect at Brigham Young University, and he's also had prior experience as a CISO and a security engineering background as well. Kevin Wilcox is an information security specialist at Appalachian State University. He's also a teaching assistant at the SANS Institute and helps support the US Cyber Challenge. And Seth Hall currently is a co-founder and employee here at Corelight, but prior to that, he spent 7 years as a frontline incident responder and network security person at Ohio State University. So he's going to be speaking today primarily to that experience, but also he's a core contributor to the BRO project. So if you have any burning BRO questions, there are a few people in the world who know more about BRO, I would say, than Seth, but certainly everyone on today's call has great in-depth BRO operator experience. So if you're someone who's just getting started with BRO in a lab environment, or you've been running it yourself, these are great people to talk to because they've got years worth of experience in their own environments. So a little bit about BRO 101, just to make sure we're all on the same page. So BRO is an open source framework. It's a network security monitoring tool. And as far as open source frameworks go, it's actually quite old. It was first lines of code were written in 1995 by Vern Paxson at the Lawrence Berkeley National Laboratory in Berkeley, California. Vern was trying to do a project around network traffic analysis and didn't have the existing tool set to get the insight he was looking for. So he took it upon himself to create his own framework, which he named BRO. Sometimes, that name gets a laugh if you've never really heard of BRO, or maybe you've only heard about it in passing, but he actually named it after George Orwell's Big Brother as a warning, because, what can be used for good can also be used for evil when it comes to monitoring tools. So he just wanted to keep that top of mind, that with great power comes great responsibility with this tool. And lastly, from a functionality perspective, BRO a lot of people, if you talk to them who haven't used Bro on a day-to-day basis, they often have different ideas about what Bro might be, and often they're all right, and they're all describing different functionalities of Bro, which is to say that it's a very multifunctional tool. But primarily, I think about Bro in three categories. One, it can comprehensively log the traffic that's crossing your network and generate these rich logs that you can use for a variety of security use cases. Two, it can extract files off of the wire. And three, it can actually automate analysis tasks. So it has its own scripting language, and you can do everything from detection to monitoring tasks, to really anything you can think of with the data that Bro generates. You can write scripts on top of that. So sometimes people call Bro an IDS. That's how they're often first hear about it. Yeah, you can certainly use it in that function, but there's a lot of other feature sets, and you're going to hear from the speakers today about how they're using it in their environment. So quickly on that first point, right, comprehensive network logging. Bro takes raw network traffic and transforms it into network logs, Bro logs. These logs are organized by protocol with key fields that have been specifically extracted and for security use cases. So over many years of iteration on the Bro framework, the people that have contributed to the open source project have really honed in on exactly the data fields you need in each of these network protocol logs to do your job as a security person at your respective organization. Just an example here, right? The Bro connection log. You can see all the fields here on the left. Sometimes people call this Netflow on steroids. I mean, you're already getting a sense that there's a lot more data that you're getting out of a Bro log than your typical DNS server log, for example, or a Netflow record. File extraction, as I mentioned, Bro can comprehensively extract and reassemble files off the wire, which is great if you have a file analysis framework tool that you want to send those files to, or if you just want to put that in cold storage for later if there's an issue that you need to go back in time and look at files that crossed your network or were downloaded on endpoints. And also Bro generates a separate log as part of its network logging capability called the files log, which includes a lot of great fields like file hashes, like a SHA-1 hash, so you can quickly look up and check it against blacklists. And also entropy measurements. You can measure the entropy of the file and see if there are changes for things like ransomware, for example. And lastly, right, Bro as a tool for automating analysis tasks against your network traffic. Bro has its own scripting language, and you can actually write Bro scripts yourself and deploy them in your own environment. And many organizations running Bro do exactly that. We spoke to one organization the other month that had written, I think, over 80 custom Bro scripts for their own environment that they tuned over the years, and we're really getting high quality alerts and monitoring, results out of these scripts that they'd written. But if you're new to Bro and you don't yet know how to write a Bro script, there's also a whole pool of community scripts that the open source community has contributed and shared, and you can access. There's over 60 of these scripts right now up on GitHub, which you can freely download and install and run in your own environment. So there's lots of great work that's already been done in the scripting front that's community driven, so you can get started and get value out of Bro from a scripting perspective kind of right out of the box. And just a quick word about deployment, because this sometimes confuses people that haven't run Bro in their own environment. Bro runs out of band, so it's not an inline solution. It feeds off of a copy of your network traffic, and there's a variety of ways to get that copy to a Bro server, a packet broker, optical tap. You just need to get Bro packets, basically. And once Bro takes those packets, then it does the other functions like transforming them into comprehensive network logs, extracting files out of that raw traffic if that's what you wanted to do. And on top of that, of course, you can write scripts. And you can send the outputs of Bro to any sort of tool that you want, really. Bro is extremely flexible in that way, or storage for later analysis. And why do people use Bro? Well, when we talk to people who are using Bro, it generally falls into one of three buckets here. They want to make faster, better incident response processes. So, a lot of times incident responders are hunting data to try to answer the questions that the security alerts have generated. So that's, begging for data access to a certain, server that they don't necessarily have access to, or that's trying to correlate two different logs together. Bro gives you kind of all the data you need right in one place and can really, really accelerate incident response time and help you resolve incidents that without Bro might not even be possible to resolve. Threat hunting and kind of threat detection generally is another primary use case of Bro. People really love it for its ability to show kind of a sequence of events with time overlaid to understand exactly how someone may have gotten inside of your network and how they moved laterally within that space. And lastly, the data itself, we like to say is kind of rocket fuel for people and tools. You can take Bro logs, you can take the files that Bro can extract and put those into your existing tool chain, or expose them to your frontline incident responders or threat hunters. And it's really just great, rich data that can accelerate all manners of processes in the security environment. And a last note here, if you are interested in learning more about Bro after today's webcast, I would highly encourage you to attend BroCon, which is the open source kind of meetup once a year. Everybody gets together. This year it's going to be in Arlington, Virginia, October 10th to 12th, and you can register online at brocon2018.com. And so with that, I'm going to turn it over to our first panelist. Fatima?
Hey, thanks, John, for the introduction. And let's get started. So Bro at University of Delaware. Okay, so this is the basic architecture of how it looks like our deployment at University of Delaware. We have been running Bro for past 3 years now. We have been a Bro shop for more than 3 years, and we have all our internet traffic routed through our core routers, and hence we get a copy of all the traffic in our Gigamon, which distributes that traffic to our 4 Pro sensors. So almost each sensor gets like almost 25% of that from that 10 Gbps of traffic, and all the logs then get aggregated by logger that is running on the Bro manager box, which is the actual Bro manager, which is aggregating the logs. And we have a retention of almost 30 days worth of Bro logs. So this is the basic architecture of our environment. Currently we only monitor the external traffic with our Bro sensors. That means all the traffic communication back and forth between our network, ASNs, and the internet, we monitor that only right now with with our Bro cluster. And we also have future plans to expand the cluster to monitor the internal traffic as well, because of all the cool advantages we are getting right from the Bro cluster that we have to monitor the external traffic. So can we go to the next slide? Okay, so why Bro? Bro is our one stop for realizing a full packet capture, which is highly necessary for doing incident responding and incident investigations. It has strong logging and scripting frameworks, as John mentioned before, that you can customize your scripts. You can write your own scripts, which allows you to customize your packet capture data. If you need if you need to include more metadata fields, or if you need to exclude some of the protocol traffics that you do not really want to see on your network, or you do not see those protocols on your network, you can absolutely do that by writing your own scripts and by customizing your own Bro cluster for detecting that, analyzing the traffic, and putting them in the corresponding log files. That's why I have mentioned that it's a dynamic full packet capture solution, because really right now what all packet capture solutions you have, they just log whatever is flowing on the network, and they do not give kind of like a dynamic capability of modulating what you are seeing and analyzing just the interested things or interested fields in the traffic. With Bro, you can absolutely do that. Each protocol, and one of the strong points of Bro logging is each protocol traffic is segregated nicely in the human readable format in different log files. You don't have to analyze the raw packets using tools like Wireshark or Tshark, or you that Wireshark filter to filter all these log files. What if I had you do not need explicit knowledge or explicit functionality for doing that. Bro automatically does that for you. For each protocol, it segregates it nicely in ASCII human readable format, tab separated log files. So you just have to, if you're interested in just one certain type of protocol, and if you're just interested in watching the logs of that protocol, then you can absolutely do that without any kind of Wireshark or Tshark kung fu. So those were the main important considerations of running Bro versus a full packet capture solution. Next slide. Okay, I have Bro running, now what? And that was the very first question that came to my mind when we had Bro up and running, and I personally wanted to get more or most out of it, not just a normal NSM product, which is just passively detecting the traffic and logging it in. So I started to look into the log files that it generates apart from the normal protocol log files, and it's interesting. Like it already generates all the protocol log files, but apart from that, you see different log files that are not protocol related, like the notice.log file, intel.log file, and weird.log file. these are some basic log files that you can quickly look through and go through to get some quick understanding of what interesting things Bro is watching on your network and what it is logging in your network. There are some really cool scripts also that are by default ships with Bro, so you don't even have to add some kind of secret sauce for generating those log files. And those interesting things found by those scripts get recorded into different log files, such as beard and notice, as I mentioned before. So we detect and block all kinds of scanners and attackers using those using our automated scripts that grabs through the notice and weird and intel.log files and put those IPs to our automatic block on the border based on the notice weird and intel log files. We use scan ng scripts available via Bro package manager to detect advanced type of scans like backscatter and knock. So for the categories of scanning, we use that explicit scan ng package that is also available on GitHub. You can directly download it and install it via either you can install it by yourself or you can use Bro Packet Manager to do that for you. We also use Bro's Intel framework to detect and block high confidence IOCs that get detected in our network traffic by Bro and gets logged into intel.log files. For using, so now I have to mention, for using Intel framework, you have to actually explicitly enable it and then load the IOCs or open source IOCs or whatever feeds you have in Bro for Bro to detect that on your network. So those were the interesting things that we just got right from the bat when we had Bro installed. Similarly, for detecting the fake Google bots, we run a simple grep command line on notice.log to find web crawlers that pretend to be Google, but actually they are not. They are using Google's user agent to kind of like mimic Google, because most of the servers and most of the websites allow Google bots just by looking at the user agent, but the actual IP addresses, they do not belong to Google. So that was another use case we had recently in PAS. Similarly, OpenVAS, DMU, these are just the strings that can be grabbed through the http.log file. I have some examples in the appendix section as well to show how those strings get detected. And you will be astonished whenever these scanners run in the default mode, you can actually get OpenVAS and CMU scanner strings as a user agent. So you can absolutely detect that right in clear text in http.log file and block or take actions on those IP addresses as well. So these were the quick things that you can quickly look right after deploying Bro in your environment or in your network. So John, next slide. Advanced use cases at UD. So apart from those quick wins, what we have done is in past we have detected couple of firewall configurations as well. So there is a really cool log file that gets generated from Bro automatically, which is known services.log and site host openport.log. So it's kind of like a mini firewall that your Bro is seeing. Not a mini firewall, but it reports all the services that are open to the internet. For our environment, as we only monitor the external traffic, Bro reports and monitors all the traffic and reports whatever services are open to the internet. So it's very interesting. Like, we have some firewall rules that block some services, but when we see those services as open to the internet, it gets curious, right? That okay, now we are blocking SSH, but why it is showing up in known services that SSH is open to your network? So we have detected some bypass and leak routes in PAS that have bypassed our firewall, and those connections were reported by Bro in known services saying, oh, I see SSH server on this network, it's open to the internet. So it was really curious. So if you know what is your firewall rules, or if you know what services should be open on your network, you can absolutely look at the known services.log file and see what all services are listed by Bro that is running on your network. You can have the valid application getting blocked as well. There are a lot of split routed traffic reported by Bro recently in weird.log file, and that was all because there was a legit application that was getting blocked at the firewall, but Bro was seeing the one-sided connections. And when we analyzed that traffic in firewall logs, it said that okay, it is blocking yum from a server, and we are like, actually yum should be allowed on that server. So this is how we analyze our Bro logs versus our firewall logs and try to figure out the firewall misconfigurations and if there is any bypass, leak, or root on our firewalls. Enumerating servers and services, this is really important, because if you have, as I mentioned, that if you have if you have services that are open to the internet, then perfectly fine. But if you know what services should not be open to the internet, like a lot of time it happens that some machines and some software, they automatically opens up the ports on the host system, whoever's installing those services, and the host might not know about it. So a lot of time that happens that whenever we're auditing, for example, our DNS servers, our HTTP servers, and when we grep through our known services.log file for all DNS and HTTP servers, every time new host shows up, and I was like, how people can actually run so many servers on a university network. So it's really helpful to answer the questions that how many HTTP servers I have, how many DNS servers I have, do I see anything special on those servers, and is there a system that is on that list but it should not be on the list, etc., etc. So that is one of our use case to reduce the risk in attack service of shutting down the unwanted services on our firewall. Lastly, policy compliance. There is a software.log file that gets generated by Bro, and it reports the software versions and software, different kind of software that it detects in the network. So I think 3 default scripts get shipped, or more than 3 default script that gets shipped with Bro that detects operating system. So if you want a policy compliance saying we should not be running Windows XP boxes on our network, and if you see the software.log and if you see the hosts are still running the Windows XP, you can go ahead and send them a notice saying you are running an old version of software which is not supported by the university, so please upgrade to the latest software. We have done that a lot in past for OpenSSL, SSH software, Apache servers, and the vulnerable services and the vulnerable software that comes out with vulnerability. We actually go through the software.log to see if we are seeing that kind of software on our network or not. So these were some advanced use cases. John, the next slide. And lastly, 2 more advanced use cases that we have recently used with Bro. Of course, malware detection. That, as I said before, that Bro is our primary PCAP solution in our network, and this is our first stop of doing any kind of incident investigation, because all the data of network we have is in Bro logs. So it is our first point of incident investigations. We have a lot of malware downloads happening on the client systems all the time. And the good thing is if you have the metadata saying, okay, the client was running Windows operating system, but this malware is actually for the Mac operating system. So it can kind of like stir your direction of incident responding as well. So we use Bro all the time for doing malware incident responding. And we had really cool cases in the past as well. Fingerprinting, that is one of our major use cases with Bro in university environment specifically, because in university it's unconstrained systems, right? Like a lot of students, all the students almost comes with more than 3 devices, and they come every session, every new session, new students come with new devices, and they just attach it to our network. So it's really important to keep a track of an inventory, to have an inventory of the systems, to keep a track of what all devices are on my network and what kind of software they are running. So we have recently built an inventory of all unconstrained systems on our university environment, with all the MAC addresses from the DHCP log and what kind of software they are running, what are the ports open on them, what are the services that are open to the internet. So we have done that fingerprinting by using Bro as a passive scanner, and it just helps you to know more and know better about your network, that how many systems at a given point in time are active on my network, how many of them are Mac OS, how many of them are Windows system. Okay, are we running some kind of antivirus, and what is the ratio of antiviruses? Like how many people on our network run Avast, how many people in our network run XYZ software. So that was one of our major use cases with Bro in past. Next slide. So I have 2 slides for the appendix. So all the quick wins I have mentioned in the previous section, you can see I have included three types of scanning. That these scannings are these scan notices are right from the notice.log in our production Bro cluster. It's not made up data. So you can see that Bro is detecting 3 different kinds of scan: knock, backscatter, and error scan. We just take those IPs. We have written automated scripts that actually looks for these kind of scannings in notice.log file, takes those IPs and then directly blocks them on the border. So and in the second section, you can see I have included 3 examples of different types of notices generated by Bro, like HTTP brute force or SSH brute forcing, and HTTP SQL injection attack. We also look for those kind of notices, notice tags in notice.log file, and we block all these IPs right away on the border. Next slide. And here are some others that I have mentioned before in the previous section of quick wins. Intel IOC, again, if you have Intel framework active, which I highly recommend to have it in Bro Intel framework, these are the notices. These are kind of like notices that gets generated in Intel.log file, where you can see that an IP that was in my IOC list gets reported by Bro that it has seen that IP on my network. It was reported by danger rules.sk sites for scanner or honeynet purpose, and it had 85% of confidence. So all the connections where we see the IOCs more than 85% of confidence, we directly block them on the border. Weird.logs, we have recently started blocking the bad ICMP checksum for the IPs after they cross the threshold, because a lot of times these are related to the scanning and different kind of flood attacks. So we have recently started blocking on weird.log file as well. Command and Kung Fu, I have included 2 command line greps, which we do and which we have a policy for blocking. The first one, you can just go and you can just grab a string openVAS from your http.log file, and if you are these show up in our logs where people are running the scanners against our networks and they are not even changing the defaults. So for openVAS and ZEMU scanners, you can just grab those strings in http.log and see if you are getting any hits in your log files. Fake Googlebot, lastly, is this log is from the notice.log, where Pro automatically detects the scanner, the web scroller scanners. And in the web crawler, if you see an IP which does not belong to Google, but it is using Googlebot as a user agent to mimic Google, we actually block those kind of Googlebots as well. So these were the quick wins, or these are the quick things that you can actually dig through the logs and get the value out of Pro. So that concludes the section of how we're using Bro at University of Delaware.
Thank you, Fatima. That was great.
Thanks, John.
Next up, Kevin.
Yeah, thanks, John. So before we jump in, I kind of want to give just a little bit of an overview of what our network looks like. We have some very simple use cases. Generally speaking, we are what you would consider the large side of a small school. We don't make it into that large category yet. So what does that mean? Well, it means that typically we're doing IDS and NSM for about 80,000 devices. We have a single /16 network that we care about as far as the internet's concerned. So typically speaking, we're talking about monitoring 60,000 public IP addresses. We have about 18,000 students, about 2,000 faculty staff during the academic year, right? So that's typically about 20,000 users. Redundant 10 gig links to the world, which really means that right now we may be doing about 500 megs a second, but during the academic year, we typically average on that 3 to 4 gig per second range. So kind of on the larger side of small, but definitely not into that large network yet. Next. So when we started looking at Bro, when we started looking at anything, right? We sat down and we said, all right, well, we have some questions. We know that we need to be able to do network forensics. We want to know what happened and when, and we don't necessarily want to have to touch a system to go out and find that information. We knew that we couldn't get NetFlow out of the gate because our hardware just wouldn't let us do that at that point. So we started looking at the conlog as an option. We knew that we wanted information about DNS. We ran the DNS servers. Actually, I ran the DNS servers at the time. I knew that we had DNS queries, but we didn't have DNS responses. And queries are cool, but responses are awesome. So Bro kind of fit that need with the DNS log. Now, what does that mean for the future of DNS when we talk about DNS over TLS? I don't know. We're gonna see how that pans out. Maybe it means better logging on DNS servers, or maybe moving Bro from network to endpoint. I don't know. We'll see. But then we had a couple of other questions, right? We knew that we had networks where we should never see IRC happening. So is there a way that we can get a log for that? We knew that we had networks where we should never see outbound FTP connections. can we get a log of what's going on? Can we get some visibility into all the plain text HTTP requests that are going on? Now, what does that mean with 80% of internet traffic now going over TLS? We will have to figure that out. But at the time, we had questions. We had questions about which TLS versions were in use or which SSL versions were in use. So after we took a look, Bro really fit that need for us. Next. Our current deployment, like I said, we're only monitoring a single /16. We're only looking at about 3 to 5 gigs of traffic. Right now, that means we're running Bro on one massive box. We're using PF-Ring to split that up into traffic for 14 workers. We are able to keep about 90 days of data, which to me is pretty awesome. But that comes at the 2.5 terabytes of disk after zipped cost. I'm okay with that. If we were collecting PCAP for a weekend, we're looking at 30 terabytes of data. So having that reduction and still having visibility was a big deal for us. The idea moving forward is that we're going to do something a lot closer to what Delaware's done. Right? We want to break that out so that we have multiple 1 gig nodes. We can run multiple workers per node, make sure we're not overloading. And then to move from that kind of default output mechanism to JSON. I'm kind of wonky. I heart all things JSON, so Bro for us is moving in that direction. And then after we're able to sort that out, then I want to start looking at data center traffic. So I know that sounds kind of weird. Let's take a look at what that really means for us. Next slide. So right now, we don't have data center visibility. The left side of that is more conceptual. That's not exactly how it looks, but that's basically how it looks. We sit outside of our edge firewall. Now, I know that sounds like a really weird place to do traffic monitoring. But with a connection log, you know if an inbound connection was rejected or blocked. Rejected or dropped. So I'm okay with that. And then by sitting on the outside of that, we're able to audit the egress rules, which are really the ones that I care the most about. From there, we feed all of our traffic into some Arista switches. We drop all the traffic to Snort. We drop another copy of it to Bro. And then from Bro, we write out to disk, and we send another copy of that data to Kafka, and then we pull that into an Elastic Stack for enrichment and searching. Next. So I said that we add some data to that. If you look at what Bro does, if you look at the logs that it generates and you look at the content of those logs, it's primarily things like IP port. You'll see host names. You'll see connection flags or connection history. You'll see things like URLs. But we wanted to add a little bit more. For example, if I see an IP address, I wanted to add things like ASN information or do GeoIP lookups. ASN information lets me say, oh, well, that massive data stream that's coming in, that came from Netflix. Right? I don't have to remember the 25 million IP addresses that Microsoft has. I can just say, oh, that big stream coming in is Microsoft. I don't have to worry about it being something like maybe a BitTorrent download or a crazy download into my server network if I know where that's coming from. Using things like source IP, we tag on that data so we can say, all right, well, we know this is coming from a workstation network or a server network. We like to add whois information. So I like to, in things like the HTTP log or the DNS log, I like to take those domain names, do whois lookups, pull in the registration date. We all know that registration info is just notoriously bad, but it's interesting to see how actors will use that same data over and over. So even though it's not correct, if it's consistent, that helps in incident response. We take that data, we do some entropy calculations using things like Freak Server. So it's nice to take that DNS log, that HTTP log, and say, oh, I have these host names. Let me do calculations on them to see if that's probably a human-generated host name or probably a DGA-generated host name. And then because we get things like inbound and outbound byte counts, inbound and outbound packet counts, we can do interesting things like, I know this many bytes came in, this many bytes came out. What was the ratio for that? Was this a 90% download and a 10% upload connection? If I see a lot of outbound, if I see a lot of outbound traffic, a lot of high ratio uploads, then I know I need to go back to my con log and start hunting down who that user was or what that system was. Next. Now, after we started answering some of those questions and doing some of that enrichment, we had some massive wins. I love the idea of looking for IRC traffic from server networks. Why? Because that was the very first incident that we caught with Bro. I came in one morning, I started looking through the Bro connection log, and I saw outbound 6667 from one of our servers. I was like, well, that's really interesting. Pivot over to the irc.log file. Oh, well, now that's really interesting. We have people from one of our servers connecting out and talking about trying to attack or wanting to attack the Australian equivalent of the National Health Service. That was an interesting win for us. We caught it within just a couple of hours of that IRC server and the IRC software actually dropping on the box. So massive win. Even though 80% of traffic now goes over TLS, as far as HTTP goes, attackers are still using HTTP. It is fantastic to be able to see where a suspected compromised system is reaching out, grabbing malware from a domain, being able to see what the domain is, being able to see what the file name is in files.log, being able to look at maybe TLS traffic and say, oh, these certs are missing information. So using the X509 and SSL logs have been massive wins for finding things like Meterpreter and similar oddities where folks are trying to cut corners in generating their certificates. Speaking of certificates, one of the things that I was really surprised by was using the SSL and X509 logs, we were able to find all the wildcard certificates that people were using in our networks. I had no clue how many servers we had wildcard certificates on until I started looking at the SSL and X509 logs. We had applications that were still running or were still allowing old versions of SSL and TLS because the admins were afraid to turn it down. Well, they didn't know what percentage of their users were connecting in with old versions, but we were able to look at the SSL and TLS or the SSL.log and X509 log and say, no, 95% of your users are connecting with TLS 1.1. 4% are connecting with TLS 1.0. You can turn down SSL 3 or SSL 2. This was a couple of years ago, the first go around, but it was nice for us to be able to go back and tell our admins, no, you actually can make these changes because people aren't connecting using these old protocols. I said that we weren't able to get things like flow data, so we were relying on things like the con log. One of the things that got us was the what everybody thinks of as top talkers. Who's doing the most traffic outbound? Who's doing the most traffic inbound? What are the super popular domains? What are the super popular networks that folks are going to? Where's most of our traffic going? Where's most of our traffic coming from? What do we need to take a closer look at? So just from the three core bro logs, con, HTTP, and DNS, we were able to answer almost all the questions that we had about what happened when and how hinky or how strange was it to happen on our network. So we have been massive fans. I proselytize for Bro every chance I get. So, John, I think you can move on to Nick.
Oh, great. Well, thank you for that. Nick, you're up.
Okay, thank you, and I want to apologize in advance to everybody. I'm getting over some sickness here, so I probably sound a little funny, but just bear with me. I'm the security architect at Brigham Young University. We are substantial Bro users. We have been using it for just a little while now, but I want to talk about just real quick my history and my former role and how I used Bro. Back in 2012 at the university I worked at previously, we had started kind of hacking around with Bro. We were looking at ways to replace our Argus and Netflow systems. In addition to that, our PCAP systems. And so we kind of started deploying some Bro sensors, some Dell sensors in network closets around campus. They were only 1 gigabit connections. They were isolated boxes. They were logging locally, running FreeBSD. We didn't really think anything of it at first. Bro was just kind of like that. Looks like an interesting tool. We'll see where it goes from here. Even just having the isolated, closet, network closet sensors, we started getting really amazing value out of it. So we ran that for about a year or so, and then starting in 2014, we built a campus-wide Bro cluster since we found the data that it was generating to be fantastic. It was really helping us with our incident response. The downside was we were having to SSH into systems and check each system locally. We hadn't matured yet to the level of actually running it against like an Elk cluster or Splunk. So in 2014, we built a Bro cluster, which completely replaced our Argus, Netflow, and PCAP systems. It was a 10 Linux node cluster that was looking at traffic on both our border and data center. It was using PF ring, and we finally integrated it with Elk, and we wrote some custom log stash filters at the time to support that. The amount of data we were getting out of it, it was mostly north-south type traffic. So when I say north-south, from the internet to campus and vice versa. We were getting a lot of awesome data, but it did require a lot of kind of tender loving care. I'll talk about that a little bit, but it was an in-house Bro development. And so we got tremendous value out of it, but we also spent a lot of time tuning the systems, making sure that we weren't dropping packets all over the place. The other thing too is we were doing a lot of Bro customization at that point. We were just kind of using stock Bro, kind of out of the box. We were using some scripts and packages that we had found on the internet to help augment some of that. But even with just the out of the box functionality, we found great value. Next slide. So in my current role, I transitioned to BYU in 2016, and because of my previous experience with Bro, we were under an initiative to kind of take a brand new look at how we were handling security at BYU, what our ecosystem looked like. Our CISO likes to say we were turning the lights on. It was a big initiative here on our campus. And so I came in and I said, well, look, I think we need to take a look at, a couple of these solutions, and Bro would be one of those solutions to take a look at. And so in 2016, it actually started off as a student capstone project and was very successful. The students actually, our central IT department provided some oversight, but our initial Bro cluster was actually built by students out of the IT program. And so they were testing everything from, how do we get, high performance packet capture out of, commercial Dell commodity hardware, what kinds of scripts can we write, what kind of visibility can we get? And then our cybersecurity research lab on campus also got involved. They built their own Bro system and started helping us with that research as well. And then by 2017, because the capstone project was so successful, we decided to go ahead and build an enterprise Bro cluster for our campus. And so the cluster consists of 17 nodes for both north-south, and the biggest win out of all this was actually east-west traffic. It's one thing when you can see traffic coming into your university and exiting. It's another thing when you can actually see the traffic that's taking place between buildings on your campus, and we have found tremendous value out of that. It's fully integrated with Elk, and that's where we handle a lot of our automation and orchestration. And then we've also started getting pretty heavy into Bro scripting and package building. And so we've built, I think, 10 or 11 Bro packages now and hunting scripts. We have found this to be really fantastic too, because universities are dealing with some interesting issues that a lot of private companies are dealing with. And so we're looking for specific things that aren't going to trigger a signature that we download in our AV clients or even our campus firewalls. And so we've had a lot of flexibility there in building some custom packages and scripts to hunt these things down. Again, the downside has been we built the cluster in-house, so there's some TLC there. We have to make sure the systems are functioning correctly, they're tuned, that we're not dropping packets, that the operating systems and the disk I/O and everything like that are functioning correctly. But even with all of that, we've had huge value out of this. Then in 2018, we decided to start augmenting our Bro system with Corelight. So we have a single instance of Corelight right now that's augmenting our Bro cluster, and we're in the process of trying to figure out how we want to sort of marry those two solutions together. And then 2019 and 2020 and ongoing, we do consider Bro a critical component in our entire security stack. My teams are getting well versed in it. We're all going through Bro developer training, and we see this going forward to the future. So next slide. Our deployment is pretty standard, like you've seen with the other universities. We use a combination of tap and span ports at various locations on our campus. We have a border connection, we have a data center ingress-egress connection, and then we also have span ports that are coming from buildings across campus. All of that is collapsed back in our data center onto an Arista packet broker or tap aggregation switch. We looked at other switches as well. Nothing wrong with them. It just one of the reasons we chose Arista at the time was because Arista and Bro, there was a script that was written, a package that allowed us to do traffic shunting, and so we had purchased Arista for that was one of the reasons we did that. You can see in the diagram we have a Bro sensor pool. That's where our 17 nodes exist, and the packet broker allows us to distribute traffic as we see fit. So in some cases, some of our buildings only produce, 500, 600, 700 megabits a second of traffic, which a single sensor can easily handle. Other areas of our campus may be doing 5 or 6 gigabits of traffic, and so we split that traffic up and distribute it across multiple nodes to make sure that we're not dropping packets and we're getting everything that we need to see. All of our Bro sensors are obviously physical sensors with 10 gigabit Miracom cards. However, our Bro Master is actually a VM, and we have found pretty good success with that, not needing to have a bare metal Bro manager on that. We also use Rundeck heavily. That's another tool that we use for automation and orchestration. We have integrated Rundeck with our Bro system. So Rundeck is responsible for not only managing the cluster, so for example, deploying new code, restarting nodes, health checks, making sure swap and memory space are under control. Rundeck also handles a lot of our heavy correlation that isn't being handled by the Elk stack right now. So for example, when we see sensitive data crossing the wire, Rundeck kicks off, goes into Bro and starts correlating all those logs together and builds basically a rolled up profile or report and sends that to Elk instead of having us send all of those logs to the Elastic stack. So that's helped us reduce the logging load on Elastic, because if you've spent any time with Bro and you're in a large environment, Bro generates an enormous amount of data, and it's awesome, but you also have to find that balance of what data do I really need into my analytics stack, what can be done with local correlation, those kinds of things. So next slide. The benefits we have found with using Bro, the first one for me is correlation. If you've used Bro, and we've talked about it in this webinar so far, Bro separates protocols and different things into separate logs, and we find that to be very valuable because the way the correlation works in Bro is very simple. Every session generates a connection ID, and you can take that connection ID and correlate that across multiple logs. So if you want to use some shell foo, if you're stuck at the command line, it makes it very easy for you to go, hey, for this particular session, how did this correlate with NTLM or Samba and CIFS and our Active Directory server? You can correlate all that together. In addition to that, you've got like the files log, which allows you which generates a file ID, and you can correlate that file ID with sessions as well. So we have found that to be very beneficial, a great time reducer in our incident response, because we don't have to jump around to different data streams. We can just say, hey, Bro, tell me what you saw for this particular session and everything related to it. In addition to that, it's really enhanced our threat hunting, and I put a star here. I can't emphasize that enough, because if you've spent enough time in cybersecurity, your signature-based systems do have a place. But when it comes down to threat hunting, you're looking for those things that your existing security systems are not picking up, or your signatures are not firing. So we've had a pretty substantial reduction in incident response time because of that. We are threat hunting on campus, and we find things that we go, hey, that would be a perfect thing to write a Bro script against. We have a PCAP that we generated, we write the Bro script against it, and there you go, we have a new threat hunting module deployed in Bro. The traffic histories and the sessions are powerful because, as you know, Bro is very session-based and allows us to keep track of what's taking place. The traffic history is also important. It was talked about earlier that we have, you have things like known hosts and known services, and Bro is actually building somewhat of a passive inventory for you as you're going on. It can also keep track of what an IP has done over a period of time, for example, port scans or things like that. And so we're able to leverage that instead of just looking at all of these, isolated isolated NetFlow logs and we see packets coming in, but we can't really draw a picture of what's taking place. We've also found the event-driven and policy framework of Bro to be very powerful. It seems to make sense when you're writing these Bro scripts and these Bro packages. You can write multiple scripts and you can collect multiple events from a particular protocol or session that you saw. We have found that to be very powerful in our development. In addition to that, the platform flexibility is pretty incredible. It's more so than what I've seen with some commercial offerings in the IDS space. Some commercial offerings will, yeah, you can tune some rules, you can provide some flexibility, but where Bro gives us a lot of power is we can really go deep down into any protocol and extract metadata out of that and take some action on it. And I've got an example of how we use that coming up. And it's a domain-specific language. There's a ton of basic input functionality that's already been written. The Bro code already knows how to slice and dice subnets and IP addresses and does all the calculations. It knows how to take URLs and extract metadata from that, URI parameters and things like that. It knows how to extract SSL metadata, and it drops that into your environment, and you can write scripts specifically against that and use the large function library that's provided by Bro. Next slide. The protocol coverage is pretty substantial. The nice thing about it is if there's a protocol that's not supported, you can write a new protocol. Although we have found that we haven't really needed to do that. Most protocols that we've really wanted to take a deep dive in, it's already been provided by the Bro community or a package that's out on GitHub. Some of the challenges that we've run into is building an in-house Bro cluster is not easy. You have to have some kind of specialized expertise. Everything from packet capture mechanics, packet drops and buffers and IRQs and interrupts, clustering, debugging that and making sure that all the Bro nodes are talking correctly. There's diagnostics and debugging. We have seen that, on our kind of commodity off-the-shelf hardware that we've purchased, we can only do about 3 to 5 gigabits per node before we start having some issues. And then you've got to make sure you're managing your I/O. Is disk I/O okay? Is what's the memory consumption? How's swap space being utilized? You have to conduct your own system administration, patching, and code compiling. And then of course there's log ingestion, which we all kind of struggle with, because if you're generating an enormous amount of logs, what system can take all that in? With Corelight, we have found that a lot of those issues have kind of been resolved for us, and we just kind of need to span and tap. We plan to continue to use our in-house Bro cluster because we find that very powerful, but we'd like to see how we're trying to figure out how we're gonna augment this with Corelight. Next slide. So stories from the war front, what we've seen with Bro, we had initial success with it, basically day one when we deployed it, and we continue to find new ways that we're using this. Our east-west detection has become very beneficial for us. So for example, we had an instance where a particular piece of ransomware was trying to detonate and spread itself across campus. Luckily, our Bro system could see what was taking place. We had actually written a Bro script to dig down into the SMB1 protocol, and it gets really technical, but we said, look, we want to see anytime anybody's using this older SMB1 protocol with this specific SMB function. We wrote a script, deployed it, and we're able to catch it. Crypto mining is the same thing. We're looking for the presence of anybody that's doing crypto mining on campus, which may indicate a potential compromise, and we've written alerts in Bro to go, look, we've got crypto mining on networks that we should never expect that kind of activity. Remote access attacks, like any university, we continue to find issues and compromises with people that have opened themselves up to the internet via RDP or SSH or anything like that. Bro has been very powerful in helping us hunt those down. We had one instance where a few systems on campus had been infected with a particular botnet, but the really awesome thing about that was that the botnet was communicating over IRC back to its command and control. We were actually able to see that. We logged into the IRC channel and we could actually see everything that the botnet was doing, and it gave us direct evidence of what exactly happened to the machines on our campus and how it was communicating with that. We're also getting sensitive data hunting, detection, and correlation. We want to look for the presence of maybe student records that are unencrypted on the wire or social security numbers. We're using Bro for that now to help us do that detection and correlation. We are heavy users of file extraction and payload analysis on Bro. This is one of the most powerful features we have found with Bro, is the file carving and payload analysis. We've been able to detect the presence of web shells that the attackers have tried to deploy. We've been able to extract payload from an HTTP session that contained very concerning or suspicious strings that we don't like to see. We've also tailored Bro to look for things that maybe your IDS sensors aren't detecting, web service error detection. So Bro is alerting us on anytime we see a web server on campus that may be showing a MySQL or an Oracle database error to the user. That's an immediate indication to us that we need to go do some threat hunting and find out what's going on with that server. And then finally, the kind of the passive inventory. We're starting to use Bro to develop a passive inventory of our systems, very similar to what the University of Delaware is doing, to allow Bro to just listen and help us understand what's on our network. Because like any other university, we have a huge rotation of students coming on in and off campus, and so Bro gives us some insight into that. Next, I think that's the last slide. Yep.
Great, thank you. Seth, over to you.
Thanks, John. I'll move along pretty quickly since we're close to the end. So I used to work at the Ohio State University. A lot of what I do now is pretty different, but I had a lot of background, at least at this transition period when NetFlow became less directly useful for day-to-day analysis. NetFlow for security kind of started at OSU because the OSU flow tools were developed there. I mean, it was like before that, as far as I'm aware, NetFlow was really only used for accounting, and we started using it, or I should say the guy that I worked for there started using it for security. And there were tools written, and it was great. It caught so many high volume things like, I mean, basically scanners. Like worms were a big thing in the early 2000s, and it was really great. So go ahead and move on to the next slide. It was so great that it almost canceled the Daily Show once. They were doing, I forget what they called it. It was the Daily Show in the Midwest, and they were at OSU. First, they asked for a network connection or an internet connection, and they got an internet connection. Unfortunately, none of their computers had ever been connected to the internet, not behind NAT. And the moment they connected them, they were infected with Slammer, and we had a process that automatically blocked them, and they were editing their video in New York, and they couldn't transfer the video there. And we almost canceled the Daily Show because of NetFlow analysis. So move on. The problem was that it wasn't so great. Around 2004, 2005, things started to change. There were the things that were being attacked were different. People weren't so interested in writing something like Slammer or MyDoom or all these. I don't remember if MyDoom worked that way, but all the things where they would just go scan the network, look for more to compromise those, and then those would look for more to compromise. Like that kind of bot scanning stuff just sort of went away. A machine would get compromised and would just sit there and not do anything and not be very visible. And NetFlow is not terribly useful for that because yes, there's lots and lots of stuff happening, but how do you actually find what matters to you? So really that was the core problem that we were running into with NetFlow, was that intrusions don't result in this massive network activity that's visible in NetFlow. Go ahead and move on. And then just due to the group's background, we were very much into this mode of log analysis and hunting. I mean, that was where NetFlow came from, like there weren't really signatures back in the early 2000s that you could apply to NetFlow. That didn't really make any sense. And so the signature mindset was not really very prevalent in our group. And what made sense to us was logs, and more logs and better logs are really what made sense. And so go ahead and move to the next slide. We started running Bro. The first thing that happened was we realized that Bro's output at the time, this was in 2005, Bro's output was great, but you had to work on it after the fact to make the logs more useful. So one day I sat down and was like, well, okay, how about we actually make Bro just output this higher quality data instead of outputting lower quality data, which we then clean up with Perl scripts and make more consumable. And literally what you're running today is the output of that process, where we just kept looking at all these different things, and it was like, what if this log was easier to consume, and what if this log was easier to consume? When I started working at the International Computer Science Institute, we took along all those scripts and sort of rewrote a bunch of stuff and turned it into Bro 2.0 and up. Go ahead and move on. So we found lots of compromises, and I don't think I really need to go over these. I imagine the slides will be available somewhere or something, John. Feel free to correct me if not. But a lot of these were already talked about. These were just lots and lots of things that we caught at the university that we would have had a very difficult time catching prior to Bro. So go ahead and move on. And I think, yeah. The real thing for us with Bro was it allowed us to continue with the way that we chose to look at the world, which was this sort of like, there's a lot of data, let's go find something, but the data became a lot richer. Yeah, and that was basically it. So I think I'm done.
Awesome. Thank you, Seth. We're at the hour here, but we'll go over 1 or 2 minutes since we got started 1 or 2 minutes late on the hour. So hopefully you can stick with us. Seth, you are correct. The slides and the recording will be made available to all attendees and registrants after the webcast. So don't worry about that. You will get a copy of these slides. Quickly about Corelight, today's webcast sponsor. So Corelight, as you may have gathered from some of the things that were discussed earlier, we make Bro an easy and enterprise-grade solution. So the open source framework is extremely powerful, as you heard from today's speakers. It can also be sometimes challenging to set up and scale in complex environments. And Corelight's kind of mission is just to make Bro as easy and enterprise-grade as possible. So we have 3 classes of sensors at a range of analysis throughput levels, depending on your environment or use case. And then from a kind of benefits perspective, it really falls into ease of deployment, high performance, integrations out of the box, and monitoring as well. So we've really made it kind of dead simple to get your Bro up and running in an environment. One of our customers, in fact, had never used Bro before and had his sensor up and running, integrated with his SIM, and had already filtered out his logs, and he got that done, he said, in about 15 minutes. So really fast to deploy, highly performant, and integrated with your favorite tools. That's Corelight just wants Bro to be as easy as possible for you to use if you don't have the bandwidth or knowledge of how to run the open source clusters yourself. We are pretty much at time here. We do have a number of questions. I'm going to try to take 1 or 2, and we can follow up with other people's questions afterwards, but I want to be respectful of people's time here. We had one question that came in at the beginning about some of the slides I was showing about Bro logs. So those Bro logs that I was showing on screen, those particular Bro logs were designed by one of our designers, and they're freely available. So as a follow-up email, you guys will all get from this webcast, we will include a link where you can go and download a copy of those logs. And in fact, we can actually ship you a printed copy that we have that we call coffee-proof Bro logs. So they're laminated a little bit and can withstand a coffee spill or two. So those are freely available. We'll give you the link as part of the follow-up email. Equally useful if you're using an open source Bro instance or using Corelight's products. It's the same Bro logs being generated. So these are really quick, handy reference sheets for you to use to understand the Bro logs themselves. I think we have time for kind of one last question here. Why don't we do this one? What Bro scripts do you folks think are most useful in university settings? Do each of the panelists have one script that comes to mind for them?
For us, when I started looking at Bro logs, it was the scan scripts, because if you can stop them during the recon phase, then they cannot move along. And recon, unfortunately, is not very stealthy, so they have to scan the network with a very heavy scanning. So the scan scripts, the scan ng packet, that was really useful, and you can just get right on top of the Bro, and you can just do whatever magic you want to do with all the IPs that are scanning your network.
Great.
We have found with our scripts here that a lot of the misconfigurations we're finding on campus are going to result in a security incident. So our Bro scripts have been tailored to look for those misconfigurations across campus, and we have found that to be very helpful.
Great.
I'm with Fatima. I'm a massive fan of the scan scripts, not because I really care about people scanning, but because we're a state institution and people using bandwidth to do network scans is not a really an effective use of state resources. So the more we can cut that kind of stuff down, the better.
Great. Seth, any closing thoughts?
I don't think that, I don't know how relevant this script is anymore due to encryption, but one that I particularly found useful was one that I wrote when I was at OSU to do, and it's part of Bro now too, to do, to identify SQL injection attacks we caught a number of cases where there would be hosts coming around and just sort of testing existing SQL injection attacks they already knew about. And so it was great because one of the things I was tasked with was to find SQL injection vulnerabilities at the university. And I couldn't just randomly poke around at, I forget what there were, like 8,000 web servers or something on the network. So I just watched what attackers already knew about and then got those ones cleaned up. So that was a lot of fun. I know a couple of other universities have done that too. And it seemed to, at least at the time when a lot of these websites weren't encrypted, it was really useful. And I don't know how many local websites at universities are encrypted these days. I'm sure there's still a number of unencrypted ones, but it's interesting to find what attackers already know about.
Great. All right. Well, that closes today's webinar. I want to thank the panelists, especially for taking the time to share all of their great knowledge with us and experience with Bro in university environments. And thank you to the attendees who dialed in today. I found this very informative. And so, as I mentioned, just quick housekeeping, you will get a follow-up email, a recorded copy of this webcast, so you can share that with your colleagues if you like. And that email will also include a link where you can go download the Bro Logs cheat sheet. Or get a copy shipped to you as well for free. So thanks so much for joining us, everyone. That's a wrap.